Yeah, I just wanted to ask a few questions, and one of them was we have worked with Professor Krishna Swamy before, and he has a quite interesting story of how he got into genetics in general and biology in general.
Yes.
So I wanted to ask whether how did you get passionate about science in the first place, and how did you get into the topic that you're currently working on?
Actually, I my bachelor degree is nothing to do with biology. It's like engineering. So my major is chemical engineering. However, I feel like engineering is not exciting because the way we think about questions is more like, oh, there's a problem here, and then you have to resolve the problem by thinking some complicated method. It's not like the question you think about it by yourself. You just have to deal with the question people encounter. But I feel I'm more kind of curious person already about the question I want to know by myself. And that's why I started thinking maybe I should leave engineering and move to something else. And by the time I just, you know, wandering around and then I feel like, oh, what should I do next for my master degree? And I find biology actually quite fascinating because I think life is a big mystery on Earth, and that's the thing I get into the research and get into biology eventually. Yeah.
That's quite interesting. Right now, you mentioned that people you encounter change you. So, I've also noticed that you mentioned that your lab involves a lot of cross country collaborations.
Yes.
Do you think cross country collaborations add something to the environment of the lab and how it works, based on how different people from across the world have different work ethics
Mhm.
or something?
I mean, yes, that I think that you can think about this in two ways. One is like the discipline. If the people are working on different discipline, actually the way they think about question are very different. So they already help a lot because you can see a more wider angle from different way to see the same question. And in terms of like for example different nationality, that's another also big plus because the cultural difference of those people and actually they make the whole lab more fun because they are from different culture and they have different things to share with. So I think no matter in scientific or non-scientific, this kind of interaction actually is much better than just have one single country or everything everybody come from biology. That I feel the diversity actually is quite useful. Yeah.
And lastly, you work on topics that are not sort of like ecology or concerning the world that is visible around us. You work on proteins and their folding patterns and those sort of topics. Do you think how should we communicate those intricacies, the technicalities of those processes to the wider masses? Do you think that's necessary to be communicated, and if so, how?
This is a tough question because I mean, in fact, I was originally trained as a molecular biologist. So everything I start actually from those very, very small things, like you are looking into the structure of a single protein and you are looking for interaction between different molecules. And to me, I already feel that part is a little bit difficult to communicate with other people. For example, when I'm talking to my parents, they never really understand why do you want to know the structure of protein for what. Yeah, and luckily, after I shift from molecular biology to evolution, it become a little bit more realistic in terms of what I'm doing to people because I always can tell people if you think about evolution, actually it's more like our daily life things because for example, like recently the COVID-19, everybody learned the virus is
Yeah.
evolving. So I can use this kind of example to tell people evolution actually are dealing with the things actually all the life forms are changing every day. Not just like in a million years, actually they are changing gradually all the time. So when you combine this kind of evolutionary view with the molecular biology, then people can start to understand more why you want to see those small molecule structures, see the interaction, because those are the basis to change. Eventually, you can see the change in those life form, right? And that's why you can justify once you know those small details, then you can start to understand how the things change. For example, like from those dinosaur and then become mammal, and that's all because they accumulate the small changes. Eventually, they change from A to B to C, and then you see the diversity of whole life nowadays is all due to this kind of force driving organism, driving the life form to change. I don't know whether I explained well to you, but at least when I talk about this, my parents can understand to be, oh, that's why, even though they don't know all those details, but they seem to see why I should get into those details, because if you don't understand those details, actually it's very difficult to understand why they change it from one form to another.
It's really interesting.
Yes.
Thank you so much for the interview.